6, 7, 8, 9, 10, and go on. Okay, that's all. How about y is equal to 1 over x? I told you before we have something like that to cusp or to like a number c. Let's say that like letter c without 0. How about if I say y is equal to x square? Look, this is the first part about the x. How about x square? We will positive this one to here, so we will transfer it like that. How about y is equal to square root of x? As I told you, we have like that, x to power 4 to power 6, any positive, even power will be like that. How about y is equal to cubic root? Cubic means that third root of x. You know, we have something like that, but we will laying down like that, and laying down like that. Okay, so please review the more the two examples here. We have y is equal to x 3 over 2 before we have a x to power 3 is like that. Now because we divide by 2, there is no root, so it just remains like that. Okay, how about y is equal to 2 over 3? As you know, we have a cubic root, we have our square root. You can see x squared like that. Now sorry, because cubic is like that for the cubic, and the other part, because you have a positive, the negative, and it's going to there, is going to there. That's why in both part you have like that. So just you need to more practice, and you can control the number 5. Okay, so I'm going back to number 3, piecewise function here. Depending on the really the graph, here's your picture. Depending on the graph, in general, depending on the basic graphs, we can draw this one. How? I know f of x is equal to x is like that. How about if I multiply by minus? If I say f of x is equal to minus x, you know, we just reverse like that, right? Okay, now I have a condition here. Look, I have a condition on the graph. He say what? He say f of x is equal to minus x, but what? The condition is what? X less than 0. Means that where's x is less than 0? Here's x less than 0. Here's 0. Here's positive 0. Positive more than 0. Here's less than 0. So in that case means that please delete this part. Why? Because here's more than 0. Here's the 0. So this one is the less than 0. That's why we just erase all the part. I'm going to say that again for you. You have what? You have f of x is equal to minus x when x less than 0. Here's x, here's minus x, here's minus x less than 0. Okay, that's about the first part. Now for the second part, f of x is equal to x squared. Okay, but where x is between 0 and 1. Look at your page, please, page number 3. So here's f of x is equal to x squared. Here's 0 and 1. Here's the positive and positive here, because you have equality. So here's my picture. I put y because here's in general, here's the greater than 0 and equal, and here's to 1. Okay, that's all. However, the third part of the piecewise function, he say f of x is equal to 1. And you know, When you say 1 or 2 or anything, any number means that y is equal. F of x, as I told you, is y. Y is equal to 1 is like a what? Like a horizontal line. So y is equal to 1. For example, if I say y is equal to 5, you can draw it like that. 1, 2, 3, 4, 5. If I say minus 5, you are going to what? 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Y is equal to minus 5. So in the third case, we have what? Sorry. In the third case, we have y is equal to minus, is equal to 1. In that case, I say this is my function, 1. In general, y is equal to 1. Okay, but the conditions say what? The conditions say x greater than 1. So means that here's 1 greater than 1 means that here, here's a greater than 1. How about the other part? It's less than 1. So I say this should be like that. Why? Because here's 1, here's less than 1, here's greater than 1. That way we will cut the value. Y is equal to 1. For example, if I say y greater than 1, here's y greater than 1. That's all. So in all that case, now I'm going to combine the functions together. So y is equal to f of x is equal to minus x squared 1. Okay. How about here? X less than, I think, less than 0. Yeah, it's a condition. How about the second condition? You say x be between and equal to 0 and 1. How about the third condition? You say x be greater than 1. Okay, now this is my turn. So minus x for the first part, I'll do it by the red. So this is the second f should be 1. Okay, how about 1 greater than 1? This is the third part. Okay, dear. So f of x is equal to minus x squared. Okay. This is your graph. It's very important and need more work. So please do not hesitate to ask me in case you don't understand the work. Now in page number, we finished number 3, we are going to deal with the page number 4. In page number 4, there's another subject for dealing with the function or type or property of the function, which was the even and odd function. Before I'm talking about the function, we have a number. When we say an even number, means that 2, 4, and go on. And we mention as a 2n or 2k, means that any number by multiply by 2. When you say odd number, mean by 1, 2, 3, 5, and we recalled as a 2k plus 1. Means that if you have, for example, you want to get 3, 2 by 1 plus 1. So this is about number. But for function, it's different. How? We have f of x. We should, please listen to me, we should test it. Okay? We should test it. If I get minus 2x, I get what? The output is what? Okay? If the output, you have 2 or 3 choices. If the output, the same function, without changing anything, we say even. If this function, after putting the minus 2 in front of each x and the result was minus x, we call odd. Otherwise, we say neither odd nor even. Not of them. None of them. Okay. I'll give you this one. F of x is equal to x. Tell me, is odd or even? Please do not think about that power, because maybe there's just some change. For example, if I get, how I get the result, how can I get the answer that's like odd or even? I should put any x. If I have x, I should put negative in front of it. And I would get what? I get minus x, which can be distinguished by, this is your function? Yes. What's the difference? What's the addition? Here's we have minus. So I got what? I got minus function. Look, here's function and here's minus function. So in that case, I say odd. How about f of x is equal to, for example, x square? Now tell me what the results, odd or even. Now you can say f minus x means that I will put negative to any x that I have, and you know is equal to x squared. So after giving minus to the function, you have a function, we gave them negative. If I got the same things without any change, I got the same thing. Look, here's the same thing without change. I say what? I say it's an even function. Now how about this function? F of x is equal to x squared plus x. Look, you should, in all the cases, you should give them negative to all of them. So I get, okay, I will give negative. In that case, I will get x squared, and in that case, I will get negative x. So this is, I'm asking myself, this is equal to my original one or negative one or none of them. Ask yourself. How can I ask? This is your function? No. So it's not odd, not even. If I multiply negative, I get that one, that result. Look, I will get negative to here. I get negative x squared, negative x. This one is equal to here? No. So this one. So means this function is neither odd nor even. Okay, dear? That's all. For example, f of x is equal to cosine of x. If I put negative, I get what? Cosine negative. And cosine never let the negative stay. So we'll change it to this. So because I put this is my original function. Okay, it's my original function. After giving the negative value, I got what? I got the same. So this is even. How a sine? Now, if I put negative, I get what? Sine negative x. When x, don't say negative sine, no. And the sine has a property, we'll see, I'm giving out the negative. So this function is equal to my original? No, but is equal to negative original, which means that odd. That's all about the function and odd and even. In the page number, and you can find all these examples that I wrote for you in the example 8 in page about even and odd in page number 4. Okay, please review it. Now we are going to what? We are going to page number 5, and we studied number 5 already. Now directly we are going to page number 6 and number 7, which is nothing, just talking about, you have one chapter I think 3 or 4. We are going to, in the between chapter 3 and 4, we are going to sketch this one and finding how to sketch that one. Also we are going to talking about the rational function. Rational means that we have polynomials, or rather poly over polynomial, another polynomial like that. Look, x squared, for example, plus 2 over x. So this is a rational function. So in this page they give it just the name. So here's the rational function, and you should find the asymptote. درکنار asymptote, maybe you have a horizontal asymptote, maybe you have a vertical asymptote, maybe you have a vertical and slant slant, okay, درکناریler or slant asymptote. That's all. And here's you have algebraic things. He told you that This is just really mentioning the name, nothing else. And he will let you to know about, we have an exponential function like e to power x to 2 power x. So here's the graph. He will give you just the capture, okay, no more detail. Also you have a log function and len function. You can see here the capture of it. That's all we call transcendental function, all these one together. So that's all about the really 1.1. and here's your exercise, and I will highlight it for you, and I'll let you know which one of them are important and include to your exam and quiz. That's all. I'm finishing my point here, and that's all about the 1.1. Thank you for being here with me. Thank you for listening video and studying your textbook.